In my last video, I discussed about the area of a sector of a circle, but I want to, before I will give examples of finding the area of a sector of a circle, I will discuss first the area of a circle segment. Before we will go to that, I have a circle here. As you can see, this one this area, it is called a circle sector. But if I'm going to the line here between S and Q, then the one that we're talking about here now, this one, this area, it is called the circle segment. Okay, how to solve for the area of this circle sector? Area of a circle sector, I will just put sector. We did before. It is the angle the central angle divided by 360 degrees multiplied by pi multiplied by the square of the radius, or we have the angle divided by 360 multiplied by the pi and the square of the diameter divided by 4. It depends. But the area of this now, this circle sector, segment, the segment, here now, segment. There are two ways that you can do. Either you will solve the area of this one first, and then solve the sector, the whole sector, by using this formula, and then solve the area of this. Or there is also a formula that you can use. You have the radius square divided by 2 multiplied by pi divided by 180 degrees times c, or times the angle, central angle, minus sine of the central angle. When I am going to give examples of circle sector and segment, finding their area, I'm going to use both of these, and I'm going to introduce also how to do it in other ways, like finding the area of the triangle and the whole sector, and then just subtract. We'll see. Now you can see the figure here now. It is one of the examples that I'm going to discuss. It is 90 degrees. Then we have the area. We're going to find the area of the circle sector. Area. Now, it is better. Of the sector. And then later we are going to look for the length of the arc. Area of the sector is always like this. The central angle, I don't know if I will use the C, but I am going to use angle, the central angle divided by 360 degrees multiplied by pi multiplied by radius square. So we have 90 degrees divided by 360 degrees is equal to multiplied by pi multiplied by, we have 6 squared centimeters squared. Then we have 1/4 multiplied by pi multiplied by 36 centimeter squared. 36 divided by 4 is 90. 9 pi square centimeter to answer exactly. How about the arc? Then we have the angle divided by 360 multiplied by the diameter times pi. Then we have 90 degrees divided by 360 multiplied by, we have 12 pi centimeter. And then we have 1/4 multiplied by 12 pi centimeter. Then we have 3 pi centimeter. That's the area of the sector and the length of the arc. Let's take a look for another. Not exactly. We have 45 degrees instead. So you have the area of the sector. That's okay. Area of the sector, circle sector, is equal to the angle, that's 45 degrees divided by 360 multiplied by pi times the radius, that is 12 squared square centimeter. Then we have 45 360 1/8 times pi times 144 square centimeter times 144, then we have 18 pi square centimeter. Length of the arc is equal to, we have 45 360 degrees and multiplied by the diameter is 24 times pi centimeter. That's 1/8 times 24 pi centimeter. Then we have 3 pi centimeter. Let's complicate a little bit. This is the third example. As you can see now, like what I said before, we have the area of the segment is really equal to the area of the sector the circle sector minus the area of the triangle. That is actually what we are doing. The area of this whole thing. Maybe I need more. That's it. The area of this whole thing minus the area of the triangle. Then we have area of the segment. There is two ways to do that, like what I said, by using a formula, but you need to memorize it. So we have that. Square divided by 2 multiplied by pi times 180 minus, I multiplied by the central angle minus sine of the central angle. That's how you do it. So radius in this line is 8, so we have 64 divided by 2 pi 180 times 135 minus sine 135. Sorry for that, and I hope you can follow along anyway. And we have 32 times 135 pi divided by 180 minus sine 135 degrees. Everything here is degrees. If we're going to solve that with your calculator, we have 32 parentheses 135 pi divided by 180 minus sine of 135. Then we will get 52.77. If it's centimeter, it's square centimeter. The other method that you can use is that you're going to build isosceles triangle. This is 6. This should be equal. And then if we call this for A and this is for B. And then we can say that this line is the bisector of the central angle. So this is 67.5, half of 135. So to find A is that sine 67.5 is equal to, no, it's not sine, it is cosine. Cosine 67.5 is equal to adjacent side, that is A, divided by hypotenuse is 6. No, that's 8. That is not 6, that's 8. So we have A now is equal to 8 times cosine 67.5. The same is true with B, but this time we have sine 67.5 5 is equal to b divided by 8. So we have b is equal to 8 sine 67.5. Now we are ready to find the area of the triangle. Area of the triangle it is 1/2 times base. The base is 2 times b. This one plus this one. So 2 times b, our b is 8 sine 67.5. Everything there is decrease also. Multiplied by the height is a, that is 8 cosine 67.5 degrees. So if you will solve that, this one will become 1. So we have 64 sine 67.5 degrees cosine 67.5 degrees. Then we will get, if you will count and calculate that with calculator, we will get 22.63. So to get the segment now, area of the segment now, area of this is now square centimeter. Segment, no, sector, sorry. Did I say sector? Sector minus the area of the triangle. So sector, area of the sector is, we have the central angle, that is 135 divided by 360 degrees multiplied by radius. We have 64 radius square multiplied by pi. So we have 135 divided by 360 times 64, and we have 24. We have 24 pi square centimeter. So now the area of the segment, if I will do that with calculator, so we have 24 pi minus 22.63, and I get 52.768. A little bit different there. 0.77, I say, square centimeter. But if you do this way, you have 24 pi minus, we have 64 sine and 67.5 times cosine 67.5. Then you will get the same answer. Then I have another here. I will give you tips how to do it. You do the same like what I did. Either you use your calculator or you do this isosceles triangle. When you solve one of them, then you just multiply by 3. Then you already get the segment, the area of the segment. So good luck, and I hope that you learn something about this how to find the area of a sector and the length of the arc and the area of the segment, circle segment. In my next video, then I will be discussing about this theorem 1, a line from the center to a chord. Then we'll see what we can do about it. So see you around, and I hope you will be there.